Hello, welcome to Proximity Math here. I'm going to go over an integral with e to the x in it. Okay, so we have the integral of e to the x plus x times this sum of cosines. So even though it looks intimidating, you would first off make a substitution with e to the x. Now, this would obviously get rid of a lot of these, and since we have du equals e to the x dx, this the term on the very left is e to the x times e to the x, and if you pair that with dx, we would get du, which makes this a lot easier. Okay, and now you can't really go anywhere from here except to split this up into two integrals because it's a sum. And the integral on the left, this looks like obviously like you would substitute something into it. If we let v equals equal e to u, using the same substitution, if you let v equal e to the u, then we would get e to the u du equals dv. Basically using the same substitution, let v equals equal to the e to the u, then cosine of cosine of v dv is sine of v, and since v is e to the u and u is e to the x, sine of v is sine of e to the x. And now the right integral, this looks like we can only do stuff with integration by parts because you cannot substitute anywhere these are some completely separate terms. So if we let this general integral be I, then I equals the integral of e to the x cosine of x dx. Well, you can let either e to the x or cosine of x be u and the other one be dv. And then you would get this splitting this expansion by integration by parts. X cosine of x, and then this, if you use integration by parts again on this with a very similar substitution, instead this time use sine of x, then you would actually get you would get in the brackets, this integral by integration of parts would become e to the x cosine of x dx. Okay, and now this is why I did integration by parts twice, because this trigonometric function cosine of x, if you use integration by parts, it won't change. I mean, it won't like go away. It'll just become another, it'll take its own derivative and then become another trig function. But this term will stay the same. Meaning if you differentiate it enough, you'll get the same integral again, maybe a different sign, but then you can express it recursively in terms of itself. So the same integral here is equal to this, meaning we can take this out and replace it with I. So I substituted over here, and now if we add I to both sides, 2I on the left side, and now just divide by 2 and get this. Okay, now we're past the only hard part, I think. So if you substitute back in this 1/2 e to, well, we used u instead over here, so you would get 1/2 e to the u is e to the x, so we have e to the x times this sum cosine of x plus sine of x. Instead for u, it's cosine of e to the x plus sine of e to the x. And if you sum those two integrals again, integrals from here, then our original integral has been integrated. This is the final answer. Don't forget to add the constant term. Thanks for watching.